Number 23 on 10.3, we get this exponential equation y, f of x is 2 to the x. We could write this as y equal 2 to the x. In, a lot of equations, you plug an x in and maybe it's going to get raised to some power, but here x is the exponent. That's what makes this an exponential equation. Okay, it's supposed to just be an equal there. If I plug in -2, that's 2 to the -2, which would be 1/4. Okay, I'm just going to fill out this little table. I put some values in. If I plug in -1, 2 to the -1 is a half. If I plug in 0, 2 to the 0 is 1. If I plug in 1, 2 to the first power is 2. For 2, 2 squared is 4. For 3, 2 cubed is 8. So I'm going to go carefully graph this. This is what they actually ask you to do in part A. I'm going to go try to carefully graph this. I'm going to turn the recorder off, and it'll show it graphed when I turn it on. Okay, so if I graph it, it looks something like that. Again, it's kind of hard for me to get the points graphed really accurately with the stylus and the iPad, but I did the best I could. Now, one of the reasons I'm a little concerned about how good that graph is that we're supposed to actually find some points from it. Well, actually, if you look at part B, let me just do part B. Actually, I'm going to do it in green because I'm going to graph in green. They want us to draw the graph of f inverse of x on the same coordinate system by reflecting the graph in the line y equal x. So let me draw the line y equal x in yellow. It's something like this. Okay. Now, I could try to eyeball that, but I'll get a better idea of the graph. I'll get a better drawing of the graph. I'm going to draw in green. If I just take the points in those tables up there, and I switch them, okay? So instead of -2 a fourth, I'll have a fourth, -2. And inverse undoes. It says that if I put a number in, I'm going to get back what I started with. So then instead of -1/2, I'll have a half, -1. Can't even get that to right. Instead of 0, 1, I'll have 1, 0. Instead of 2, 1, 2, 2, 1, then it'll be 4, 2, and 8, 3. Now what I'm going to do is, again, turn this off and graph in green this inverse as best as I can. All right, I tried to use the table to do that in the points, and again, my stylus is hard to hit exactly where I want to hit, but that's a pretty good representative of f inverse of x. Now again, the reason that I'm a little worried about these graphs is that if you look at part C, they want us to find some values. Part C, they want us to find f inverse of 2, okay? So now, if I wanted to, I could just come over here and look at the table. When I plug in 2, I get 1. And if you look, that's what I tried to graph over there in the green was 2, 1. Where am I going to actually get it? I'm going to pull it off this table over here because I know the table's more accurate than my graph. Then they ask for f inverse of 4. So if I plug 4 into the inverse equation, what do I get? And again, that's right here at 2. And then f inverse of 8. I just picked points that were easy to graph in the first graph, and then when you turn it around, because I wrote the table down, that makes answering these questions a lot easier than looking at that graph. Though I could look at the graph if I graphed it well. And remember, you should be able to graph it pretty well on your table because you've got a piece of paper, on your graph, you've got a piece of paper with graph marks and a very sharp pencil tip, unlike this stylus point that I'm using here. And then f inverse of a half. So if I plug in a half, what do I get? Oh, that was up here, -1. So we could answer those questions pretty easily. Now D, I'm going to try to fit that down in here, but let me write it in purple just so that you can see where it is, okay? D asks us to find the domain and the range of f and f inverse, okay? Now, I can look at this graph and figure that out. For f, this is going to be hard to fit in here, but I really need to be looking at my graph in order to do this. For f, I tell you what, let me color code. Since I graphed the original function in blue, I'm going to write its domain in blue and its range in blue. For the domain, I can plug in any x I want to, so it's all real numbers. For the range, if you look, I don't have any points on that blue graph that are 0 or less. All my points for my y's are greater than 0. They're not actually equal to 0. I started to put that there, but it's just y greater than 0. Of course, I've messed that up trying to emphasize it. Y greater than 0 because it doesn't actually ever touch 0. Now, one thing that's interesting about the inverse is that the domain for the regular function will be the range for the inverse, and the range for the regular function will be the domain for the inverse. And let's just do it without thinking about that and then just notice that that's what happens. Down here, my domain on my green graph, if you look, it's x's that are bigger than 0. Okay? And then my range is my y value. My y values, I can get anything I want to eventually, so it'll be all real numbers. Okay, so let me point out what I was mentioning before we actually looked at the graph. If you look, my domain here was all real numbers, and my range over here was all real numbers. So the domain of one is the range of the other. Now let's look at the range up here was y greater than 0. Notice down here the domain is x is bigger than 0. So the bigger than 0 part stays the same. Since it's range, we always put y's. Since I've switched to domain down here, I'll change that y to an x. You can always say that the domain of one is the range of the other, and the range of one is the domain of the other on these inverse functions. That's how they work. And by the way, we've just graphed something here that you're going to learn about in this chapter. This is actually the graph of the log function. A log is the inverse of a exponential function. This is actually log base 2 of x that we just graphed here, and they didn't tell you that. They just were having you do this example because they know that they're going to talk about this later in this chapter, and so they're kind of giving you some hints as to what's to come. This log function down here would have been hard to graph had I not just taken this original table and switched it like I did. And that's how we actually graph things called log functions. They're the inverses of exponential functions, and we graph them by taking the exponential function, making a table, and then just flipping the points and getting a table to graph the log function. That's how we actually do it.